Yeah, I want to talk about Gradle 3.0, and that is a big topic because a lot of fundamental stuff is happening. So we're super excited about what is coming, and let's start with the Gradle daemon. Who of you is using Gradle with the daemon? And who of you had ever to kill the daemon? Yeah. So one thing we will do in Gradle 3.0 is it will be enabled by default, right? And that puts some pressure on the daemon to capture some cases where it might be causing trouble and confusion, right, to our users. At the same time, even though it's very easy to enable the daemon, especially with the non-power Gradle users, most do not enable the daemon, and that is a big performance penalty, as you all know. So in a way, it's for a big part of the community, it's the biggest performance improvement we can do is to enable the daemon by default so that they don't have not to do it. And one part is what we want to do better is tell you more about what is happening with the daemon. So let's, I make the fonts bigger. So there's some 500 submodule build, and let's say I'm going to start that build. What do I do? Right. And first, the messaging is getting better. The daemon is started, and let's start the daemon again. Sorry, let's build a project, the same project, in a different tab. And what you see now here, another Gradle daemon is busy, so that's why we're starting a new Gradle daemon. That has happened before, but you had no idea what was going on, right? So another thing that you will see is let's do something like Gradle classes -d org Gradle JVM args mix whatever. Oops. What I wanted to see is let me quickly check something. Oh, that's correct. What did I do wrong? What I wanted to show you is a different message. Why is this not happening? So I want to see the message that this is incompatible with a running daemon, and that's why we are starting a new daemon. Not sure why this is not happening. I think the arguments are correct. Okay, an idle Gradle daemon with different constraints could not be reused because different memory allocation for the daemon, right? So even if it's the same, we theoretically could use the same daemon, but you want different memory, so we tell you, hey, there's another daemon running, we can't use it because different memory constraints. Another thing that is interesting is let's run this daemon with 128 memory, and something should happen. It's already slow because of the memory situation. Daemon is stopping because the JVM tenured space was exhausted, right? But it's not. This is brand new. This is master, but it's not stopping. That's interesting. Maybe because it's already happening at configuration time. Okay. Anyhow, this is a non-release version, so just that you get an idea what is happening. Here we go. Now we get an out-of-memory exception, exactly what we wanted to prevent. Anyhow, that will work once M1 is out. So the key problems we see with the daemon is that people don't have a good idea about what is going on, and especially developers that are not the build masters, and we want to tell them we want to tell them what is happening. And at the same time, we want to also basically proactively react. So when things are getting close to out of memory, instead that people wondering what is going on, why is this compile now taking, I don't know, 1 hour, right? We just say, hey, we stop the daemon and tell you, you have a memory issue, right? That's much better than what is going on. Why is this build so extremely slow? So there's a lot of cool stuff happening to basically to provide a good user experience when the daemon is enabled by default. The other thing I'm very excited about is a feature called Composite Builds. I go immediately back to demo mode. So what we have here is, if you look at projects, you see project A, B, and C. And those projects are completely independent. This is not a multi-module build. Project A, Project B, Project C are separate builds, right? And if you look, for example, into Project B, right, you see Project B is actually a multi-module build with 2 sub-projects, B1 and B2. So what if you want to build them together? What if you need to work on Project A and on Project B at the same time? And Project A depends on Project B, right? And you do some changes in B, and you want that A is picking them up. What would you do currently? Fun? Crying? Yes. Or do something like run Project B, publish it to a repository, and then Project A is picking up the changes. It's not convenient, right? So, but we now have composite builds. It's still work in progress, but it's already very exciting what I can show you. So we have now the root, if you like, the root of this. It is just, this hierarchical structure is just for convenience purposes, right? They don't have to be in one directory structure. So this is now a composite project where you can define different Gradle builds to be built as a composite, right? And when I now say Gradle, show me the dependencies of that composite, something interesting is happening. So you see Project A has a dependency, right, on B1 and B2, and this is automatically replaced with a project dependency of Project B, B1. Right? So Gradle understands automatically, okay, if that is the composite, I scan all those different builds, whether they have an external dependency on one of the other builds, and if they have, I change the dependency setup, and instead of retrieving the external dependency from a repository, the other project I depend on will be built, and the output will be injected into that project, right? So, and the way that will be working eventually is you have a warning here that all participants will be executed in a single daemon process, right? And but eventually those builds can have even different Gradle versions, and it will work, right? Different daemon settings, different whatever, right? So they are decoupled, but still the output and the input relations are honored, and you can work with them as if they were one build, right? And this works already to set it up on IDEA. So, come on, build file. Could not execute Gradle installation. That's weird. Null pointer exception. Let me quickly check something. No idea what's going on here. Another brand new feature. I usually switch to pre-recording my demos, and I know why. So you have the project here, right, in IDEA, and I did it before. And what you can see here is that IDEA will automatically or Gradle will automatically create a metadata for idea that project A is not depending on external dependencies, but that they are translated to module dependencies in idea, right? So you can work on that as if it were one code base, refactoring will work, etc., right? But as soon as you execute the build outside of the composite, it will be completely able to run standalone and retrieve external dependencies, right? So this is one important piece to make multi-project scenarios much more convenient for developers. That you have basically a fluency to decide when you have multiple repositories, I want to work on multiple repositories at the same time, or I want to work on them in isolation, right? And the roadmap also, one important step for the roadmap is that you can even execute the composites on different machines. So that would be our entry into distributed builds and distributed execution of builds, right? And I think it's a nice granularity. So it scans all those builds, right? So there's a pre-processing phase where we scan those independent builds and say, hey, what are your dependencies, right? And then we see, just look at project A at the build file. Let's, 1 second. Let's go to project A. And you see this is just an external dependency on org sample B1 1.0, right? But the B project has a group ID, and it has this group ID, and so we know, hey, and the artifact ID. So we know this project corresponds to that external dependency, and then we have mechanisms in Gradle to replace that, to ignore basically that this is an external dependency and substitute it with the project dependency that is built locally. So another area where we have made massive improvements over the last 4 months is performance. So who of you is already using Gradle 2.14? Well, the release candidate. So who is using Gradle 2.13? Right. So with 2.13, you saw already some nice performance improvements, but there will be even more significant with 2.14. Right. So for many builds, we cut the configuration time at least by a factor of 2, for a few builds by a factor of 3 and more. So that's pretty spectacular, right? So the configuration time improvements. We're not at the end of that effort, but it's absolutely substantial. So if you have a chance, Gradle 2.14 release candidate 1 is out. I think tomorrow we're going to release candidate 2. So 2.14 is definitely a release you should pay a lot of attention to, because things will be much faster. Another thing we have improved in 2.13, I think, was that script compilation time. So before the scripts are cached, when you check out a fresh project, compilation is much faster of the build scripts. Another thing we introduced in 2.13 is that test execution is much faster. So when Gradle runs tests, there is a forked JVM that is running the tests, and the JVM that is running Gradle, and there is inter-process communication happening. So we sped that up, and we sped up the time to fire up a JVM that runs the test. So that is pretty significant. If you have, especially if you have many modules in your build, right? It's easily multiple hundred of processors. So that is in 2.13. What we started to do in 3.0 is we tackle dependency resolution time. So when you check out Gradle Master, what we did there as a first step, in our local cache, right, we used Ivy and POM XML to store the metadata, right? And we have changed that in 3.0 to a binary representation format, right? And which is significantly faster. So we saw some significant speed-ups in dependency resolution time, and there's much more we're going to do in the area of dependency resolution. Caching across builds, very excited about that, especially for Android. That is super important. There's more to come, parallel resolution, making dependency resolution faster when you do parallel builds. So that is an area we're investing a lot of time. And there's so much more we're going to do. So performance is top priority, and you can expect, I would say, with every minor release for the next 6 to 12 months, significant improvements. So we're pretty excited about all the stuff we're going to do, and to make Gradle a very, very, very fast build system. Who of you is building Android applications with Gradle? Yeah, so for Android, dependency resolution is even more important because they have all this variance, and the number of configurations they need to resolve is much bigger than for a typical Java build. So for them, they will benefit most from the improvements here. So the other thing that in our very focused effort to improve the performance is what we have realized, that dynamically typed Groovy code. So if you write your plugins in Groovy, or you have script plugins that are pretty complex, you pay a significant performance price for that. Depending on the plugin, there is no fixed price, I can tell you, but we had a couple of plugins where refactoring dynamic Groovy code to Java made applying the plugin 3 times faster, right? So so one thing there are various things you can do, right? One is you rewrite the plugin, you convert the plugin to Java. That is what we are doing in the Gradle core, but it's not the most convenient experience, right? It's a different API. You're moving from the DSL to the API, right? So there's some unintuitive stuff you need to do. It's possible. Look at the Gradle code base, see how we are doing things. That's a good example. So that is definitely one way to get much better performance, right? And at the same time, it can be quite involved. If you have big scripting plugins, right, you need to now turn them into a plugin project where they get compiled and all that. So it's one way to do it. It's not the most convenient way to do it. The other thing you can do is Groovy has a not well-known feature that is called compile static. So you basically can create Groovy code that is not dynamic, right? And that might, just Google for compile static and you will find that. That is another way to do things. But at the same time, it's not the experience we want to provide to our users eventually, right? And that leads me to the next topic, and a big part of the Gradle 3.0 story. Gradle goes Kotlin, right? So we are embracing Kotlin as another language to write Gradle builds, right? So, and I want to talk about the motivation for that. So first of all, how did that start? It's kind of an interesting story. I mean, initially I was just impressed, or we were impressed with the Kotlin language and with the uptake, especially in the Android community. Who of you has ever used Kotlin? So, who of you has ever heard about Kotlin? Okay, so I should say then something about Kotlin. So Kotlin is a language founded by Andrei Preslav, who is working for JetBrains, and JetBrains is the company behind that language. They have 20 engineers, right, working on that language. It's a statically typed language with all the things you expect from a modern language, right? First order functions, extension methods, and a lot of smart features. At the same time, it is much easier to learn than, let's say, Scala, right? You can learn Kotlin in 3 days, and you will be more productive than you are with Java, right? And it is backwards compatible down to Java 6. So it is, and it has a lot of uptake. I know Netflix is now hosting the Kotlin Meetup, right? So many people are interested in that language. In Android, it has already a strong following, and for us, it presents a wonderful opportunity. What is the pain that we're trying to address with Kotlin, right? So first of all, who thinks the Gradle IDE integration is completely perfect and couldn't be better. Yeah, so no one. There are various reasons for that. And one key reason is that dynamic Groovy code is very hard to support smartly in an IDE. The other reason is that Groovy support for Eclipse is no longer working, right? There are no resources behind that. It's a real problem, right? We want to provide amazing IDE support for our users, but with Groovy, that would be a major mission for, let's say, our company to do that, or for anyone else. And still constrained by some of the qualities of the language. And the other thing is scaling build logic, right? So I talked already about performance, what you get from statically typed languages. And IDE support is also a big part of scaling build logic, right? You want to have the same code navigation, move from your build script to your custom plugin that you've written to the Gradle core. You want to have that navigation capabilities that you're used to from writing production code, right? To be able to deal with complex build logic. And Stefan talked about that, right? How many Gradle builds you have. So this is a 280 engineer organization, and it's a complex piece of your engineering. And often the domain of building and delivering software is as complex as the business domain, right? So builds have changed over the last years, and we need to address that, right? So the good thing with Kotlin, there is just no downside, right? You can create wonderful DSLs, something you could not do with Java, right? It's very scripting friendly. So the reason why we picked Groovy over Java years ago as the build language is that it's just so much more convenient to use for our users, right? And with Kotlin, we have more or less the same convenience, but no downside, right? IDE support that works, statically compiled code. So we're very excited about that. So when we came to that point, Gradle and JetBrains, we started to discuss. I expressed interest in Kotlin, and JetBrains was very excited about that. So we put our heads together, and I'll now show you a demo for Gradle Kotlin support milestone 1. So what we have here is a simple Java project, right? So a Java application, it has a hello world class that has a main method and prints some very sophisticated statement, hello world. So, what you're seeing here is an almost empty Kotlin Gradle build script, right? And let's get started. How do you apply a plugin again? With apply. Thanks IntelliJ. And what was the name? What is the name of the plugin to build applications with? It's the application plugin, right? Okay, so let's look at the quick document. Let's use the quick documentation lookup, right, to learn about the application plugin that goes into the Gradle Java doc. And we see, okay, the plugin can be configured via the application plugin convention object. So let's look for the configure method, and let's look for the application plugin convention object, and let's configure the thing. And now it's getting interesting. What are the properties of that convention object? Main class name. I need to specify the name of the main class, the fully qualified path. It's package samples, hello world. Let's do that. Right. That is the Java application that we want to build, the main class for that. And then there are some other properties. Application name. What is the name of the application? It's Kotlin demo. And yeah, not going to the Gradle DSL dev reference web page and whatnot, right? It's available. And what I just did, I just clicked Command B to jump into the application plugin convention class. So I'm now in the source code, right? And I can do the same for the application plugin itself. So it's seamless navigation from, from the Gradle source code to your plugin source code base. Now we need some dependencies, right, to run the tests. So boom, repositories, Maven Central, dependencies. Now it's getting interesting. We're still working on making the syntax nicer. That's how you do it at the moment. Test compile. At least the documentation lookup works. Adds a dependency for the given configuration. And we add the JUnit for 1-2 dependencies. So now let's see if we can actually run this build, right? Maybe it's just a IDE fake. So what we're doing, run Gradle, run the tests, and here we go. Kotlin told Gradle what to do, right? Tests are run, everything is working. We run, now we run the application, right? You see hello world. We can change that text. We just go to the production code. Kotlin night, that was from last week. And you see hello Kotlin night. And let's do one more thing. We can install this application, right? And we can now look at, this is the application name. This is the jar for the application. Those are the start scripts. Okay, and the last thing, just to show that everything is working, we execute the start script of this application. Here we go. So, we cooperated with that, with the JetBrains folks. So those 4 engineers created that. It's amazing stuff, and we're making progress very fast. If you want to try it out, there is the Gradle script Kotlin repository, right, where you can find the sample I have shown to you, and you can fully reproduce that, right? That is available, right? You can play with it. There's some inconveniences in there still, but this will all get polished. So we speak more about that on our blog, Kotlin meets Gradle, if you want to get more background. So common questions are, will existing plugins work with Kotlin Gradle builds? Yes. Whatever language you use to write your plugins, Java, Groovy, Scala, Kotlin, it will work. What about Eclipse? That's the exciting thing. The JetBrains guys also provide a Kotlin plugin for Eclipse. So you will get much better Kotlin support on Eclipse than what you have now with Groovy. Will the usage of Groovy become deprecated? No. We expect there will be Groovy build scripts for the next 5 years, right? And so it will not be deprecated and will continue to be supported. So our roadmap is, this is the beginning. So especially in regard to the DSL, there's a lot of smart stuff we want to do. For example, that you have also content assist for adding dependencies to compile, test compile, configurations, and things like that. So, but we are moving very fast. So this is something we want to have production ready this year, right? And usable earlier than that. So Gradle 3.0 milestone 1 will have experimental Kotlin support 1.0 milestone 1. So what is interesting to understand, the Kotlin support at the moment lives in a different repository so that you can update a newer version of the Kotlin support without being forced to upgrade to a newer version of Gradle. We want to have, for the incubating period, separate life cycles. But in 3.0 M1, it will be embedded, right? Only if you want to update to a newer version of the Kotlin support, you need to do something. Otherwise, Gradle 3.0 M1 will have Kotlin support out of the box. It will be production ready later this year, and the detailed roadmaps will be published over the next weeks. Okay, so we're super excited about that. IDE support, faster builds, a wonderful language. Right? that I think has a very, very bright future. So yeah, before I hand over to Stepan, a couple of words to the Gradle momentum. Yeah, we had 10.4 million downloads in 2015, 1.95 million downloads in April, so last month. 800 plus community plugins, growing fast with support for any language and platform. They are, it's amazing. When I look at the plugins, there's so much technologies I have never heard of, right? And they are supported. Growing support for platforms, Java, Android, CC++, LinkedIn contributed, Python and Hadoop support, and of course, a very good Kotlin support. So, generic automation platform to model all aspects of continuous delivery. That is our vision. Okay, thank you, and Stepan, looking forward to your talk.